Everyone. In today's short lesson, we're going to talk about different types of relationships between two variables. In other words, we're going to talk about cause and effect. So at this point, you guys should be very comfortable if you're given a set of data points, creating a scatter plot, creating a line of best fit, making predictions using that equation line of best fit, finding the correlation. Is it strong? Is it moderate? Positive, negative? Those are all things you guys should be comfortable doing, especially using technology, maybe Google Sheets. But analyzing data involves much more than just finding a line of best fit. And finding a correlation coefficient is just one step in understanding how things are actually related to each other. So just because you find a correlation between two variables, it doesn't necessarily mean that one causes the other. It's important to consider how and why there is such a correlation. And so we're just going to do a very straightforward little motivation problem together to illustrate this idea. And then you guys are going to, I posted a PDF of a tiny bit of reading for you to see the 5 types of relationships that are possible if correlation exists, and for you just to get an example of each one. Instead of me just kind of talking at you. So anyway, let's get to this motivation problem. Here is some data. Now I haven't made this into. I figure you guys can take 30 seconds and enter this data into a spreadsheet program. But we're going to look at the correlation between these two things: the average price of a dozen eggs and the average price of a home in Guelph, Ontario. So it doesn't matter what year this is. So when the price of eggs was $2.49, average price was $2.50. So these are a lot bigger than, maybe this was like mid to late 2000s or something. But we're going to just look at a relationship here. So I have this data here, and I'm going to insert a chart. And in this case, I've just asked for we're just going to look, we're not going to make a line of best fit. We're just going to, well, we are, in order to find the R value. So click on a data value, add a trend line, and I want to show R squared. Show R squared. Where are you, R squared? I don't see you anywhere. Maybe if I make it bigger, actually, probably it's hiding somewhere. Trend line. Use equation. Okay, I think you have to show the equation actually to get the R squared value. So we got our equation anyway, but there's our R squared value. So heading back to my presentation here, we got that R squared was 0.965. Let's put my pen tool here. So remember, that's not the correlation coefficient, that's the square of it. So I'll just write this off to the side. R squared equals 0.965. And so if we square root that, we get our correlation coefficient. And here we know that it's positive. We saw as much with the graph. The root of 0.965 about 0.98. So the type of correlation, like, it's very strong positive. So we looked at this data set, we looked at their correlated, and we've seen that the price of eggs and the average price of a home are very strongly correlated. This is a very, very high correlation coefficient. So does that mean that increasing the price of eggs would tend to increase the price of homes in Guelph? Let's say that you were, had power over policy of pricing eggs, and you wanted to drive up the home market, could you just increase the price of eggs? Or if you wanted to decrease the price of homes, could you decrease the price of eggs? So obviously this is all really silly, right? Obviously not. Increasing the price of eggs wouldn't directly increase average price of homes. That's silly. What this is an example of is a common cause relationship. This is not a cause and effect. Increasing the price of eggs doesn't increase the price of homes. That's really silly. Instead, there's a common cause that's causing both variables to change in the same way. That's causing both variables to increase. In this case, the common cause is inflation. Right? Over time, things just go up in price. Salaries, wages go up incrementally over time. Wages and price of homes, price of groceries kind of creep up as well. And this creep is called inflation. So, it's important not to jump to conclusions. If you see two variables have a strong correlation, it doesn't mean one causes the other. And I think most of us probably already had some level of understanding of that, but I think this motivation problem just hammers it home. So there's 5 different possible ways to classify a relationship between two variables. If you find that there's a correlation existing, there's 5 different possibilities. Those 5 are cause and effect. So, and you guys will be, instead of me just putting some words that you write down, I have you guys just looking up these in a bit of a reading I've posted and just getting an example down for each one. But just really briefly, cause and effect, then that's actually where one variable, causes the other. Like you smoke more, your risk of lung disease increases. A common cause relationship, which we've just seen. A presumed relationship where you kind of assume there's a relationship, but the reason why is not exactly apparent. Reverse cause and effect, where you just have your independent and dependent variables switched up. For example, if you found obviously there's a relationship between smoking and lung disease. And if you imagine smoking as your independent variable, you smoke more, your increase of your risk of lung disease will increase. But if you flip-flop those two variables, that would mean, having a higher risk of lung disease causes people to smoke more, which is kind of silly. So a reverse cause and effect is where you've just mislabeled your two variables, you flip the axes. And accidental, where, it just might happen where you might be looking at your two variables and how they're related. Maybe because you have a small sample size, you actually find that two variables are correlated when actually there's really no relationship at all. And so that's called accidental. But, again, instead of me just kind of lecturing on this and just like making copy a bunch of stuff from the screen, I'm having you guys just kind of look at it at your own pace. You can copy down what you want. You can copy down the full definitions or just jot or whatever. It's up to you. Afterwards, after you get these definitions copied out onto your lesson sheet, I've got a short quiz for feedback on Brightspace. So I'll just have some scenarios and have you identify the type of relationship. And I've given you some suggested practice. You can try all of it. You can try none of it. But you should know these types of relationships and be able to identify, if I gave you a scenario, be able to pick out which one of the 5 it is. So big idea for today, guys. Just because you get a R value that's strong, it doesn't mean that one causes the other. There's many different ways variables can interact with each other. So that's it for today. Told you it was short. We'll hope you guys stay well, and we'll see you soon.